Professor.
Good afternoon.
Oh, last time we covered session 2.3, and then we done for the page 2. Okay, last time we stopped here. Okay, right, guys. Session 2.3. Last time we finished the page 2, the film 2.3.2. Okay, we stop here. Okay, right, guys, ready, right? Okay, so next one. Another film. If two lines are cut by a transversal so that two alternate exterior angles are congruent. So exterior alternate angles are congruent. This is talking about which angles? 1 and 6, right? In here. Right? Alternate interior angles. So 1 and the 6, that will be the alternate interior angles. And if these two angles are congruent, then these two lines are parallel. Okay, so this is kind of like the if and only if. Okay, if and only if film. You could think about like these one. Okay, at the beginning, the first page, we have this film. If two parallel lines cut by a transversal, then the pairs of alternate interior angles are congruent. So here is angle 1. If these two lines, L and M, are parallel, then angle 1 will be congruent to angle 8. Right now, they are doing like another way around. So if Q, then P. So if these two angles, angle 1 congruent to angle 8, then L is parallel to M. Okay, so this is a if and only if formula. If and only if film. Okay, then. So look at here. Suppose that angle 1 congruent to angle 3. Okay, angle 1 congruent to angle 3. Which lines must be parallel?
A and B.
A and B. Okay, good. This is called the corresponding angles. Remember, like this is the F, the letter F. Angle 1 congruent to angle 3. It implies that this is a corresponding angles. So A is going to be parallel to B. Okay, right? Angle 1 congruent to angle 3. You could see the letter F like here, right? So pair A and B will be parallel. Okay, one more questions. If A and A is parallel to B, what is the relationship between angle 2 and angle 3?
The corresponding.
2 and 3 here, this is not the letter F, right? Think about it one more time. If A is parallel to B, what is the relationship between angle 2 and angle 3?
Supplementary.
They are supplementary. Okay, supplementary because means like angle 2 plus angle 3 will be 180, right? That is our interior angles on the same side will be supplementary. Okay, right? Okay, how about this one? Try this one.
So she actually is turned away from me like that because she was most likely nodding out on heroin. Well, she definitely was. I have another picture that was taken like
Yes,
either right
anyone?
it's way more obvious, but I will not be sharing that because I feel like that's not.
Lady Nunez, you're not muted.
Oh, line C and line D.
Okay, first I want to know if angle 3 congruent to angle 8, what is the reason?
What's the exterior angles?
Exterior
Angles.
angles are congruent, right? That's a mistake here. Hold on a second. Exteriors, alternate exterior angle. Okay, one more time here. Angle 3 congruent to angle 8. So these two angles going to be alternate exterior angles. And these two lines is going to be parallel. C and D are parallel. Okay, right? So like the corresponding angle, alternate interior angle, alternate exterior angles, all this film is gonna be if and only if. Either these two lines are parallel or the angles gonna be congruent. Or those angles congruent, so these two lines are parallel. Okay, right? If and only if. Okay, this one. Given the line L is parallel to M, and then the transversal T here, cut by the transversal T. Angle 3 is congruent to angle 4. So when you guys prove the L is going to be parallel to N. Okay? Okay, one more time. You already know L is parallel to M. Okay, so you can use the corresponding angle, alternate exterior, interior angle. Now I want you guys try to prove L is parallel to N also. Hey, can you guys just try to do it by yourself, okay? And then we're gonna check the word after. You guys good? You guys should be able to do this one, right? Just think about it. We have corresponding angle, we have an alternate interior angle, and also we do have a vertical angles, right? Either those angles are congruent, then these two lines are parallel, or these two lines are parallel, so those angles are congruent, right? And then the given L is parallel to M already. Okay, so just think about it. What is the relationship between angle 3 and angle 2?
They're vertical angles.
Vertical angles are congruent, right? Angle 3 is congruent to angle 2, vertical angles, because, okay, how about angle 2 to angle 1?
They are congruent. They are corresponding angles.
Good. The angle 2 and angle 1 are corresponding angles, right? Because these two lines are parallel. So you know 3 equal to 2, and 2 is equal to 1. Okay. So does it mean angle 1 congruent to angle 3?
Yes.
Okay, right?
Yes.
Okay, now just look at this picture and then we just think about it before you guys write it down, okay? So step by step. Now, first one, write it down to give an information. Right, this is a given. L parallel to M, angle 3 congruent to angle 4. This is a given. You should have this one, right? At least, right? Even though you don't know how to do it at all, at least you guys get partial credit for this part. Given. Okay, now we say that angle 1 is congruent to angle 2, right? This is the letter F, right? Letter F. So that will be corresponding angles are congruent. You guys have this one, right? The letter F, one more time. So the letter F is going to be look like this. This is angle 1, this is angle 2. And this is two lines are congruent, parallel, right? Okay, then you know angle 2 is congruent to angle 3 because that's a vertical angles. My vertical angles are congruent. Okay, so remember what is this? If angle 1 congruent to angle 2 congruent to angle 3, what would happen with angle 1 and angle 3?
They're congruent. The
They're
transitive
congruent.
property.
What, I'm sorry, what is the reason again?
The transitive property.
Transitive property. Remember the relation like the ARB, BRC, and then ARC. Okay, transitive property. Let me write it down here. ARB and BRC. So you know ARC, right? This is ARB, BRC, so ARC, the transitive property. Okay, if angle 1 congruent to angle 3, what would happen? Angle 1 with angle 4.
They're congruent because of transitive property.
They are congruent also, right? Angle 1 congruent to angle 3. And you know angle 3 is congruent to angle 4.
Transitive
So
property.
angle 1 congruent to angle 4, that's a substitution. Right? We substitute here. We substitute angle 3 with angle 4 here. So I got this guy, substitute.
Why can't it be transitive?
Transitive, if you have a transitive, you need one more things, right? If this is transitive, it can be, it can be transitive. This is ARB, BRC, so ARC, right? Yeah, you're good. Jeffrey, you can use the transitive property. You're right. Both of them are correct. Either substitute or transitive property. Okay, so we prove angle 1 and angle 4 are congruent. Okay, and remember angle 4 and angle 1, this is also the corresponding angle, right? If angle 1 congruent to angle 4 by corresponding angle, then the line L is parallel to line N. Okay, so I assume you guys should be able to do this kind of the proof. Okay, like some proof I know is like kind of complicated. I won't put it on the exam, but like the question, something like that, you guys should be able to do it. Okay, if you guys good for this one, I want you guys try to do the example 3. Okay, example 3. Make sure you state the reason to support your equation. Okay, I need you guys state the reason to support your equation. Trigonometry. Okay. So I want to find x if so that the line L is parallel to M here. Can you guys tell me what is the relationship between angle 1 and angle 5?
Corresponding.
Corresponding angle, right? The F here. Angle 1 is going to be congruent to angle 5. Right? Corresponding angles are congruent. Make sure you stay the reason to support your equation. And then you're going to substitute. Right? The angle 1 equal to x over 2 plus 35. Angle 5 equal to 3x over 4. Hey, remember how to solve the x here? How? What is the LCD?
4.
4. Good. So I don't want to deal with the fraction, so I'm gonna multiply, find the LCD first. Find the LCD of 2 and 4. So after you find the LCD, multiply the LCD for each terms. Okay, remember those steps, right? Find the LCD, multiply the LCD for each terms. Okay, and then simplify it, right? So you're gonna get, you divide it by 2 here, so you have a 2x plus 140, and simplify this guy, you go to 3x. Hey, make sure you guys know how to solve the equation, okay? Solve the variable. And then you subtract the 2x for both sides, you're gonna get x equal to 140. Okay, question? So on the test, you may have some questions like to finding the angles. Okay, just like this one. And then make sure again, state the reason to support your equation. Or you may have the questions like the previous example, the proof. Okay. Okay, so film, if two lines cut by transversal so that the two interior angles on the same side of the transversal are supplementary, then these lines are parallel. Okay, so again, it's just like the if and only if statement. Okay, like talking about on the same side, like here, angle 3 plus angle 5 equal to 180. Sum of these two angles equal to 180, then these two lines are parallel. Or angle 4 plus angle 6 equal to 180. So these two lines are parallel. So same idea with the exterior angle, okay? Supplementary. So angle 1 plus angle 7, sum of angle 1 of angle 7 equal to 180, then these two lines are parallel. Or angle 2 plus angle 8 equal to 180, then these two lines are parallel. Okay, again, if and only if. If two lines are each parallel to the third line, then these lines are parallel to each other. So this is similar to questions that we cover here. Okay, if two lines are parallel, like L parallel to M, and then each of them is going to be parallel to N, then these two lines are parallel. I'm sorry, one more time. If L is parallel to N, and M is parallel to N, it implies that L is going to be parallel to N. This is also the transitive property, just like the relation, right? If two coplanar lines are each perpendicular to third line, then these two lines are parallel to each other. Just think about it. If I have two lines, I have a plan, and I have two lines here. And these two lines are perpendicular to the third line. This is the third line here, perpendicular. Okay, if this is two lines are perpendicular to the third line, that means these two lines are parallel. It makes sense, right? Okay, that's it. 2.3. And then 2.4. Okay. We just talk about the lines here, and then chapter 2.4, we're gonna talk about like the angles. Okay, the angles of a triangle. Okay. The angles of a triangle. A triangle, the symbol is gonna be look like that one. Okay, it's obvious, right? The triangle is the union of these three line segments. So the triangle can be formed by the three line segment. And then these three line are non-collinear points. Okay, means like they cannot join it with the same straight line. So we use the three line segments to join a triangle. Okay. So the triangle in the figure below, you could call this as angle ABC or BCA or CAB. It doesn't really matter because this is a triangle. You could start at any point here. Okay, unlike like the rectangle, we have the 4 points. We have to call it like in order like clockwise or counterclockwise. Okay, each point ABC is what of the triangle? Look at your notes here. Each point, angle A, angle B, and angle C. How you call these 3 points?
Angles?
Mm-hmm. Anything? How you call these 3 points? Like, okay, how about you only focus on this one? How
Linear.
can you call? Say again?
Non-collinear.
No, they're talking about like the point. It's not talking about the relationship between the ABC. We call the ABC, that would be the vertex. Okay, the vertex of the triangle. Okay, write it down on your notes. Each point here, we call this is the vertex, vertex, vertex. How about this line segment? AB, AC, and BC. These 3 lines will be the size of the triangle. Okay, the size of the triangle. Hey, write it down on the notes, okay? The notes here is like missing. How about point D? What is a point D? It's in the what of the
Interior.
triangle? Interior, good. Point D is the interior. So point E will be on the triangle, right? How about the point F?
Exterior.
Exterior, good. D will be inside the triangle, so we call this as the interior. E is going to be on the triangle. F, that would be exterior of the triangle. Okay, right? Okay, and then triangles may be characterized by the length of their size. So look at the table here. It will present each type of the triangle. The first one, just like the scaling triangle. The scaling triangle means number of the congruent sides. They don't have any sides that equal to each other, just like regular the triangle, scaling triangle. And then the second one, isosceles. Isosceles triangle means they have a 2 congruent side. Okay, means like they do have an equal measure, these 2 lines. You could see these 2 lines here will present they're equal to each other. And we call this as isosceles triangle. And this one called equilateral. Equilateral means these 3 sides, they do have the same equal measure. Okay, try to remember the name here. Okay, so when I say isosceles triangle, you know that 2 sides will be congruent. Okay, equilateral is going to be 3 sides, it's going to be congruent. Okay, another one. This one, acute angle. Remember what is the meaning of acute angle?
Less than 90 degrees.
Good. Angles are going to be less than 90 degrees. Okay, that's called acute angle. How about obtuse angle?
Greater than 90.
Say that again.
Greater than
180 degrees.
Greater than
that-
90 degrees.
Greater than 90.
But less than
This
180.
angle, one obtuse angle means the angle is going to be between 90 to 180. Only one angle will be between 90 and 180. This is called obtuse angle. How about right angle?
Exactly
90 degrees.
90 degrees. Okay, right? Obtuse angle means one of the angle will be between 90 and 180. Hey, you guys really need to remember all the properties like of those names. Later on, I will just say obtuse angle, so you 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 can imagine like what is the pictures looks like. Okay. Okay, equiangular. Equiangular angles means all the angles congruent. So think about it. If I know these three angles are congruent, what is the degree? How many degrees of each angle?
60.
60.
50. Good. How you get that?
180 divided by 3.
Good. Okay, so I stay here. Equiangular. It's going to be 60. $60 for each angle. Okay. Okay, right? Equiangular means 60 degrees for each angle. Okay, example 1. Angle triangle HJK, or we don't have the picture here. HJ equal to 4, JK equal to 4, and the measure of the angle J equal to 90 degrees. Describe completely the type of the triangle represent. What kind of the triangle is going to be?
Isosceles.
Isosceles only?
Right triangle.
Say it again.
Isosceles. Right triangle.
Isosceles right triangle. Good. You could try to sketch the picture. You know that's a 90 degree. So for sure, the angle is going to be look like this way. And then based on the letter, this is going to be the J, right? Either this is H, J, K. Okay, and then HJ, this line will be equal to 4. K, JK, here is also equal to 4. Okay, so when a triangle with two sides are congruent, we call this is isosceles triangle. And because of one of the angle is 90 degrees, so white angle here means the 90 degree. So we call this is a white isosceles triangle or isosceles white triangle. Okay, right? Next one. Auxiliary line, helping line. An extra line need to complete a proof or problem in the plane geometry. So sometimes if you want to prove it, you may want to add something on the picture. Okay, this one is called helping line. Okay, let's see this film. In a triangle, sum of the measures of the interior angle is 180. You guys should be understand this part, right? Interior angle talking about angle A, angle B, and angle C. Sum of these three angles will be equal to 180 degrees. Okay, and remember how to call those angles. Okay, we said we don't want to say just angle A or angle B. Okay, we want to see like CAB. Okay, talking about angle A, or ABC. So talking about angle B. BCA talking about angle C. Okay, sum of the interior angle is going to be equal to 180. Okay, now we want to use the picture to prove the film 2.41. So we want to prove this is a white film. How can we prove the interior, sum of the interior angle is going to be equal to 180? So given triangle ABC, and then this is what we want to prove. Sum of the interior angle equal to 180. So now I will be using this line, the helping line here. I want you guys draw a straight line, pass through the C. And this line called ED, line ED. will be parallel to the AB here. Can you guys try to do that? Do it on your picture, okay? Draw a line, pass through C, and then this line called ED, and this line will be parallel to the line AB. Try. Write it down on the notes, and then try to do this on your notes in here. Draw the helping line. Done? In line called ED, which is parallel to the AB. Let me know if you're done. Good. Okay. Look at my picture to see if you guys have something like that. Okay, the line ED, which is parallel to the AB. And I just named the triangle, angle 1, angle 2, and angle 3 here. Okay? Okay, now I try to use this helping line to prove sum of the interior angle equal to 180. Okay, first, what is the relationship between angle 1 and angle 8?
Alternate interior angles.
Good, alternate interior angle, right? Because ED is parallel to AB. So angle 1 will be concurrent to angle CAB. How about angle 3? Will be concurrent to which one? Angle 3 will be concurrent to what?
CBA.
CBA. Good. That's a Z here, right? Like this. So angle 3 will be concurrent to CBA. Same reason, right? Alternate interior angle. Okay. Okay, right? One more time. Angle 1 concurrent to angle CAB, and angle 3 concurrent to angle CBA, because alternate interior angle. And also, we know measure of angle 1 plus angle 2 plus angle 3 equal to 180. What is the reason?
It's a straight angle.
Straight angle. Straight angles are 180. Good. So we have right? We just talk about angle 1 concurrent to the angle CAB. Angle 3 concurrent to angle ABC. ABC or CBA, talking about the same angle. And then, can I substitute to this equation? I know angle 1 equal to CAB, so I replace the angle 1 with CAB, replace the angle 3 with the ABC here. So I'm gonna get this. Substitution. Make sense to you guys? Angle, replace the angle 1 with CAB, replace the angle 3 with the ABC. Substitution. Hey, what is the angle 2? Angle 2, actually, that is equivalent to BCA, right? Angle 2 is equal to BCA. They are talking about the same angle. So can I replace BCA to the angle 2 here? Okay, this is exactly the same angle, angle 2 and the BCA. Right? I'm sorry. So this is what we prove. Make sense to you guys? Okay, right? So sometimes when we want to prove the theorem, we may want to try to add something on it. You could do whatever you want, but you have to stay it on the proof here. Okay, you can't just add the line and do it on your own. You have to stay there, draw a line, pass through which point, and then name the line here. Okay, I call this line is gonna be ED. And then ED will be parallel to AB. Okay, done. Okay, next one. A film that follows directly from a previous film is known as a corollary of that film. Like the corollary means like most of the time film, they do have a lot of the details information. Corollary will be followed by the film, but it's gonna be a short proof on it. Okay, so it's kind of like the similar. Okay, so this one, each angle of equiangular triangle measures 60 degrees. Okay, we just talked about it from the previous slide, right? Equiangular. Okay, equiangular means they do have the same measure. Okay, angle A equal to angle B equal to angle C. Okay, and we know sum of the triangle is going to be 180 degrees, and you know they are equal to each other. So it's going to be divided by 3. So that's why each angle is going to be 60 degrees. Okay, because of equiangular. Okay, angle A equal to angle B equal to angle C. Okay, so 60 degrees for each. And when you have the equiangular, it's also the triangle, equiangular triangle is going to be also equilateral. The 3 sides are equal to each other. Okay. For the triangle, equiangular means equilateral. Like they have the same angles, so they do have the equal sign here, the equal measure for the side. And then next one, acute angles of the right triangle are complementary. Remember what's the meaning of complementary?
90 degrees.
90 degrees. So if you have a triangle, they do have the right angle. So right angle here is already 90 degrees, right? So when you have a 180 from this picture, sum of the triangle is going to be 180. And I already know angle A is 90 degrees, right? So if I take out the angle A, it will be 90 degrees. So you know angle B plus angle C is going to be 90 degrees. So that's why they say acute angle. Acute angle means the angle that's less than 90 degrees, they are complementary. So angle B plus angle C equal to 90. Okay, right? Okay, next one. If 2 angles of the one triangle are congruent to 2 angles of another triangle, then the third angles are also congruent. So this means like I have these 2 triangles, ABC and DEF. And look at the picture. This means like angle B will be congruent to angle E. Angle A will be congruent to angle D. Okay, if it is the case, then the third angle, angle C, will be congruent to angle F as well. Okay, so this is going to be another corollary. Okay. Okay, now I want you guys try to prove this film. Okay, I given Angle A congruent to angle D. Angle B congruent to angle E. I want you guys to prove angle C will be congruent to angle F. Okay, give you the first one to give an information. And then make sure, hey, just remind you guys, congruent, it implies that the measure of the angle is equal. Okay, I show you the second one. Like many students skip like this step. When they say congruent, you have to tell that like it implies that the measure of the angle is equal. Okay, think about how to do it. Any idea how to prove it? Give you guys a hint. Think about what some of the interior triangle, some of the interior angles of triangle equal to 180. Okay, so you do have a two triangle. So here angle A plus angle B plus angle C equal to 180, right? Same idea with this one. B plus E plus F is also equal to 180. Okay, try. Okay. So the next one, measure of angle ABC will be equal to 180, right? And angle DEF is also equal to 180. Okay, in a triangle, sum of the measures of angles are 180. Interior angles. Okay, so you know angle A equal to angle D, right? Angle A equal to angle D, angle B equal to angle E. Can I use the substitution to think that angle D plus angle E plus angle C equal to 180? I substitute the first one here. Substitution. Okay, I substitute angle A equal to D, angle B equal to angle E, plus angle C equal to 180. Okay. Okay, after substitution, so look at the second one here. These two lines, these two equations, both of them equal to 180. Right? I could say these two lines are equal to each other because both of them equal to 180. Again, substitution. Okay, right? So the next step, you could use subtraction property, right? We subtract angle D, subtract angle E for both sides. So you could say angle C equal to angle F. Subtraction property of equality. And we are not done yet, okay? What is the final step?
Angle C is congruent to angle F.
Good. Remember, we want to solve angle C congruent to angle for F, not the measure, right? So need one more step. Equal measure applies congruence angles. Okay. Question? Hey, one more time, remind you guys, like congruent, even though you know their congruent means the equal measure, you have to stay on it, okay? Like you know the equal measure, it should be congruent, but you have to stay here. Okay, next one. When the sides of a triangle are extended, each angle that is formed by a side and extension of the adjacent side is the exterior angle. Okay, so this is the triangle. This is the triangle ABC. I try to extend the line, the BC here to get the D. Okay, just keep drawing on this line. You could see the exterior angle. Okay, you could do the same thing. You could extend the line AC. Okay, extend the line AC here. Then you will have an exterior angle here. And same idea with AB, you will have an exterior angle. Okay, or AC extend here, you're gonna have the exterior angle. So you can see in the picture here, I have 1, 2, 3, 4, 5, 6 exterior angle. Okay, exterior angle. So total of 6 exterior angle, 2 at each vertex. For each vertex, you do have a 2 exterior angle. And then angle A and angle B are 2 non-adjacent interior angles for the exterior angle ACD. Okay, A and B is a non-adjacent interior angle. Okay, you could see A and B is not touching the exterior angle in here. Okay, so think about it, A, B, they are not with this exterior angle. So we call this as a non-adjacent. Okay, and they do have the relationship between these 3 angles. Here, angle A, angle B will be, sum of these 2 angles will be equal to the exterior angle. Hey, I want you guys to highlight this one. Sometimes you may need to use this equation though. Okay. The 2 interior, sum of these 2 interior angle will be equal to the exterior angle. And make sure these 2 interior angles are non-adjacent. Okay, non-adjacent. Okay, highlight this one. Angle A plus angle B equal to the exterior of angle C. And write it down on your notes, okay? Your notes missing this equation. We need this equation on the notes. Okay, if you could, try to do this example. Set up the equation and make sure you state the reason to support it, okay? Hey, I give you guys the first step. Hey, tell me what is the angle, which angle have the relationship in here?
3 + 5 = 1.
Good. 3 + 5 = 1. Good. Reason. What is the reason?
The measure of an exterior angle of a triangle equals the sum of the measures of the two non-adjacent interior angles.
Hmm. Good. Okay, right? And then you're gonna plug in here. Okay, solve for the x step by step. Okay, check your work. So when you have the preference, make sure you guys distribute it one by one. Okay. So you should have this one. Check your work. Combine the 9 terms on each side. So you will have 10x equal to xx plus 16. Got that? Okay, subtract the xx for both sides, divided by 2. Okay. So x equal to x. And then you need to find the angle 5. Okay, so put it back, x equal to x in here. Okay, make sure you find the angle 5. You should get 43 degrees. Make sure for your final answer, if this is a degree, stay the unit, okay? The degree is the unit. That is. Okay, come back at, take a break. Come back at 3:15. Oh no, 50, no. 10 only. 3:10. Okay.
We're gonna be moving on to 2.5, right?
Okay, guys, sorry. Try to work on. Okay. Session 2.4. We done 2.4, right? Oh, yeah, we done 2.4, sorry. Okay, so 2.5. Okay, you have your notes ready, 2.5. Okay, converse polygons. Ready, right, guys? Converse polygon. A polygon is closed plane figure whose sides a line segment that intersect only at the endpoints. So I want you guys highlight two things in here. To be a polygon, it has to be closed figure. Okay, highlight the closed figure. And also it has to be the line segment. Okay, line segment. It has to be the straight line. The line segment and closed plane figure can be created polygon. So examples are like this. Okay. Okay, this is all the polygon. Okay, closed figure. Okay, there's a no hole here. There's a closed figure. And also each line has to be straight line, the line segment. Okay. How about this one? Is it a polygon? First, is the RST, is this a polygon? Yes or no?
No,
Why?
it has a curved.
Yes. The
doesn't look like-
TS here, this is not the line segment, right? So this is not. How about the WXYZ? Why?
It's not closed.
It's not closed, right? This is an open figure. And this one?
No.
No, right? It's not the line segment. Okay, so these three guys, this is not the polygons. Okay, so remember the definition for the polygon: closed plane figure and also use the line segment. Okay, the straight line here. Okay, now you guys know what is the polygon. Then we do have two guys in here. First one is convex polygon. The polygon, we generally consider those are convex. The angle measures of convex polygons are between 0 and 180. Okay, so you're gonna know for each angle here, it has to be in between 0 and 180. And another one is a concave polygon. Okay, concave polygon. Okay, from your book, they say the concave polygon. If you could draw like two sides in here, when you draw this, how can I say? If the line segment can be drawn from the concave polygon, if that would be the exterior, then this is a concave. Okay, it's really complicated. I'm gonna teach you guys how could I know if this is gonna be convex or concave. And then let me finish this part first. Concave polygon is always at least one reflex angle. Reflex angle is talking about the angle between 180 to 360. Just like here, this angle, this is greater than 180, right? This angle should be 180, in between 180 to 360. Or like here, this angle is in between 180 to 360. So that will be the concave polygons. Okay, and that is my way. I have another way to tell if this is going to be convex or concave. Like if I try to draw the extent size, and the size is going to be the exterior, then that will be the convex polygon. For example, this is the triangle, right? I try to extend the side here. Okay, I extend it, and then you can see the line here. Extend here, 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 here. You can see all the line that I extended is always on the exterior. It's not in the interior. Okay, one more time. If this is the convex polygons, when you extend the lines is always stay in the exterior. Okay, it's going to be the exterior. So this is going to be the convex polygons. And here, if I try to extend the lines like this one, you can see my lines is going to be the interior. Okay, if the line is going to be the interior, then that will be the concave polygon. You guys see the difference, right? All the convex, when you extend the line, will be in the exterior. If the concave, some of the lines, when you extend it, that will be in the interior here. So that will be the concave polygon. Okay, so in this slide, I need you guys remember which one is going to be the convex polygon, which one is going to be concave polygon. And also highlight this one. The convex polygon is going to be the angle between 0 and 180. But for the concave polygon, there at least one angle is going to be between 180 to 360. Okay. And then convex polygon. They do have the length for each polygon. And then this is the number of the sides. Like the triangle, we know that we use the 3 sides to make the triangle. Okay. Quadrilateral, this is going to be the 4 sides. Pentagon, 5 sides. Hexagon, it's going to be 6 sides. Okay, that's a specific name for number of the sides in here. Okay, you could try to remember a little bit here. If I say that's a hexagon, you're gonna know that will be 6 sides. Okay, right? And then review a little bit. Equilateral means all sides are congruent. Okay, previous sessions we only talk about this triangle. Okay, here it can be anything. Equilateral, all sides are congruent. Equiangular means all angles are congruent. Okay. So let's try to use the Venn diagram. The P, the letter P, the rectangle here, this is represent all the polygons. And then we can have the T represent the triangle. And then the Q, that will be represent your quadrilaterals. Okay, so triangle is the 3 sides. Quadrilateral is going to be 4 sides, right? So you can see they are, both of them is going to belong to the polygons because they are closed figure, and also they use the line segment to form the figure. So both of them belongs to the polygons. But you could see they don't have the intersection. Okay, we could say the T and the Q, they are disjoint. Disjoint means they don't have anything in common. Okay, so think about it, triangle and quadrilaterals is 2 different things. Okay, one is 3 sides, one is a 4 sides. Okay, they all, both of them belongs to the polygon, but they don't have anything in common. So that's why they do have a disjoint in here. Okay, next one. Diagonals of a polygon. Diagonals of a polygon is a nice segment that joins 2 non-consecutive vertices. Just like this example. If I want to draw a diagonal, it has to be connect A to the C. I can't connect A to the B, right? If I connect A to the B, this is not the diagonal. This is going to be the 9, 7. Okay, so that's why they say two non-consecutive vertices. This is A, B, C, D, E, F, G. All of them are vertices. Okay, non-consecutive, two non-consecutive vertices. So you could skip the B, A, C, or A, D, A, E, or it can be A, F also. That would be called the diagonal. Okay, figure below shows the hexagon. Okay, A, B, C, D, E, F, G. How many sides we have? 1, 2, 3, 4, 5, 6, 7. 7, right? The 7 sides in here. And we have the GAB, angle B, BCD. This is some of the interior angle here. And then we do have the exterior angle. When we extend the line, angle 1 will be exterior angle. Angle 2, angle 3 are some of the exterior angle. And then AB, BC, CD, or DE, this is going to be the side, okay, the line segment, the side of the heptagon. Yeah. Okay. So this just talking about this is going to be the diagonal. Okay. So look at the figure, look at the table here, the triangle. Can we get the diagonal here? No, right? When we join the S and T, this is the side. When we join the S and R, this is the side also. There's no way we can have the diagonals in the triangle. But for the quadrilateral here, we do have 2 diagonals. Pentagon, we do have 5 sides, and we also have the 5 diagonals. Okay, hexagon, we have 6 sides, and we have the 9 diagonals. But sometimes it is really hard to find out how many diagonals do we have. So we will have the formula here. Highlight this formula. This is the total number of the diagonals in the polygon of n sides is given by the formula. So the D talking about how many diagonals do you have. The N talking about how many sides. For example, for a triangle, how many sides do we have?
3.
3. So n equal to 3, right? So let's say we want to know how many diagonals for the triangle. We're gonna plug in n equal to 3 into this formula. Okay, let's say I want to find out how many diagonals of a triangle. So we plug in n equal to 3. So you're gonna get 0. Okay, I need you guys to remember this formula. N represent the size of the polygon. The D will be the how many diagonals will you have? Okay. Try the example 1. Okay, write down the formula. So try example 1, A and B. Okay, do both of them, A and B. Find the diagonal number of the diagonals and then find the type of polygon. Okay. Okay, first, what is n equal to for the A here, pentagon? How many sides do we have?
5.
N equal to 5. Good. And then we're gonna plug into the formula. What did you guys get?
5.
5. Right? We subtract it first, and then the 2 and 2 you cancel out. So you should get the 5. So for the pentagon, you do have a 5 diagonals. Okay. Okay, how about this one? You know, the polygon has 9 diagonals. So you're gonna plug in back d equal to 9. Okay, d equal to 9, right? Do you guys get this? And then multiply by 2 for both sides. So you're gonna get 18. And then distribute the n 1 by 1. So you should have n squared minus 3n. So we write it, this is a ax squared plus bx plus c equal to c equal to 0. Remember the quadratic formula? You guys know how to solve it, right? Okay, either using the x formula, the x method, or you can use the quadratic formula. Hopefully you guys remember that from the algebra. Okay, so you factor out, you will get this one. You have to know how to do that, okay, in the algebra class. You should learn it from the algebra class. And then use the zero properties. So n minus 6 equal to 0 or n plus 3 equal to 0. Got that? So n equal to 6 and n equal to negative 3. So would you have the 2 answer here?
No. It's
Why?
possible. You can't have negative diagonals.
No, n is talking about the side, right? You can't have a negative sides, right? This is the side of the polygon. So we reject this answer. So you're gonna have a 6 sides with 9 diagonals. Okay, so the hexagon has 9 diagonals. They just want to find out what type of the polygon. So that would be the hexagon. Okay, right? Okay, some of the interior angles of a polygon. Okay, let me talk a little bit this one. Some of the interior angle for a polygon. So for example, we just learned the triangle, right? Triangle. Let me put it back better. We have, okay, we have the polygon. And then we have the size. How many sides you have? And then you could think about number of the triangle. And then you could find some of the angles. Okay, I show you guys the first one. First one, triangle. How many sides do we have for the triangle? 3. Number of the triangle? Only 1, right? So what is the sum of the interior angle? for the triangle?
180.
180. Good. Right? So you could say one triangle, we multiply it equal to 180. Okay, second one, the quadrilateral. How many sides for the quadrilateral?
4.
4. Give me 1 second. Okay, we have 4 sides. Okay, so think about it. If the quadrilateral, we do have the 4 sides, how many triangles can we have? 2. Good. I cut it out. I do have a 2 triangle. So here I'm gonna put 2 triangles. So think about it. If one triangle is 180, when I have a 180 degree, right? 180 degrees, sum of the interior angle, and this is a 180 as well, right? So how many total degree in here?
360.
260. So I could say 2 times 180, that would be equal to 360. Am I right? Okay, keep going. How about the pentagon? How many sides do we have? 5. 5 sides. 1. Oops, I cannot do that. My goodness, it's disappeared. Okay, 5 sides. How many triangle? Let me see if I could do here. 1, 2, 3, 4, 5. Yeah. How many triangle do we have? So 1, 2, 3, 4, 5. 5 sides, right? So I can cut 1 triangle, 1, 2, 3, 3 triangle, right? So here I could say, okay, I have 3 triangle. Each triangle is going to be 180 degrees. So 3 times 180, that will be 540 degrees. Make sense to you guys? So think about it. If I keep going doing like that way, let's say I have octagon. How many sides do we have?
6.
8 sides,
8. Yeah.
right? 8 sides. How many triangle do we have? 6 triangle. Okay, if you're not sure, you could try graph it here. Okay, exercise 1, 2, 3, 4, 5, 6, 7, 8, like that one. Okay, so you could cut it. You should have a 6 triangle in here. Okay, I didn't get a good job here, but if you write like the 6 sides, you could cut it like 6 triangle. So the sum of the triangle, sum of the angles, that will be 6 times 180, which is gonna be equal to 1080 degrees. Okay, so if you keep going on it, you're gonna find, let's say I have an n size of the polygon. Okay, the n size of polygon. So the line is gonna be the n. And then you could see the patterns. When you have a 3 sides, you do have a 1 triangle. 4 sides, you do have a 2 triangle. 5 sides, you do have a 3 triangle. This guy is always subtract 2. So here, that will be n minus 2 here. Make sense to you guys? Okay, 3 sides, you have a 1 triangle. 4 sides, you have 2 triangle. It's always subtract 2. 3 minus 2, you get 1. 4 minus 2, you get 2. 5 minus 2, you get 3. 8 minus 2, you get 6. So here, the general formula will be n and n minus 2. So I gotta doing the same thing. N minus 2 times 180. Okay, this is gonna be the sum of the interior's angle. Okay, so you could see, I just set up the formula here. And this is the theorem, the S of the measure of the interior's angle of a polygon with n sides is given by n minus 2 times 180 degree. Highlight this formula. The S here talking about the total of the interior's angle, sum of the interior's angle. Okay, highlight this formula. And n has to be greater than 2. Okay, highlight this formula. Okay, right? So the next example, I want you guys to try, find the S. Find the sum of the measure of the interior's angles of a hexagon. Okay, so think about it. How many sides do you have for the hexagon? What is n equal to? And then plug back to the formula. What is your n equal to?
6.
6. Good. And then you're gonna plug into this formula to find out sum of the interior angles. What do you guys get?
Four
54.
times.
4 times 180 equal to
720.
720 degrees. Good. So the hexagon, the interiors of angle, sum of the interiors angle will be equal to 720. Okay, so these sessions, you do have two formula. One is finding the diagonals. One is finding the sum of the interiors angle. Good, okay, right? Okay, how about in equiangular hexagon? Remember what's the meaning of equiangular?
All angles are the same.
The angles are congruent, right? All the measures, all the angles are congruent. So each of the 6 interiors angle measure how many of each angles equal to?
80 degrees.
How you get that?
720 divided by 6.
Good. The total interiors angle is 720 degree, right? And then they do have a 6 interiors angle. And since they are equiangular, okay, so you're gonna divide by 6. So you have a 120 degree. Good. Okay. Regular polygons, okay? Regular polygons means they will have a both sides and angles are congruent. Okay, so A here, the figure A, this is equilateral. Equilateral means like all sides are congruent. Okay, the sides are equal to each other. B here, this is equiangular, means all the angles are congruent. C, we call this as the regular. Regular means they are equilateral and also equiangular. Okay, all sides are equal and all the angles are equal. Okay, remember these were regular polygons, equilateral and equiangular. Okay, so that's a definition. Regular polygon is a polygon that is both equilateral and equiangular. And then the measure I of each interior angle of a regular polygon or equiangular polygon of n side is so this is talking about they want to find out the interior angle, okay, for the equiangular. Hey, look at the formula, n minus 2 times 180. Remember this, okay, look at this formula, n minus 2 times 180. This is exactly the same formula. We got it for the s, n minus 2 times 180. Okay, this is talking about once you find the sum of the measure of the interior angles, if you could divide it by how many sides you have, how many angles do you have, then you could find out the interior angle, right? Actually, we did this part already. The whole thing added up together, that will be the I in here. Okay, divided by n. Okay, so one more time, on the top, this is just like the s divided by the I. Let me put it here. 1 second. Okay, you could see the S talking about sum of the interior angle. Okay, S over N equal to the I here also. Okay. Okay, right, write it down, S over N. Hey, write it down on your notes also. Your notes doesn't have this formula. Put it on your notes. And again, this formula only apply for the regular polygon or equiangular polygon. Okay, it doesn't work for the equilateral. Okay, try this one. Okay. Okay, this one. We want to find the measure of the each interior angle. We want to know this angle. Okay, and this is gonna be the Euclid angle opticon. Okay, so what is your n equal to? How many sides do you have?
8 sides.
8 sides. Good. So you put in n equal to 8. Right? Take care of the frequency. So you have a 6 times 180 divided by 8. Hey, try to simplify before you multiply. Okay, so I could simplify the 6 and the 8. Right? Divided by 2. I got 3 in here, 4 here. I could simplify these two. Divided by 4, divided by 4, I'm gonna get 45. So 45 times 3, you're gonna get 135 degrees. So each angle here, that'll be 135 degrees. Okay? Okay. Next one. Okay, Carl, 2.5.4. Sum of the measure of the 4 interior angles of a quadrilateral is 360. Actually, this one we could use the formula, right? Or you could use just the picture. Quadrilateral, so you have a 4 sides. So think about it. This is going to be 90 degrees for each of them. Right? So 90 degrees times 4. So it's going to be 360. Okay. And the second one, sum of the measure of the exterior angles of a polygon, one at each vertex is going to be 360. One at each vertex is going to be 360. So this one, let me see. Talking about like, it can be like any angle. When you draw the exterior sides, like here, here, and here, we do have a 3 exterior angle. Okay, angle 1, angle 2, and angle 3. And when you add up these 3 angles together, that will be equal to 360. Okay, it's not only applied for the triangle, it's all the polygon. Like any polygon. For example, I have 1, 2, 3, 4, 5. Like this picture. If I try to get the exterior angle here, one at each vertex. Like this. Okay, so I have a 1, 2, 3, 4, 5. Okay, so when I added up angle 1 dot 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 plus angle 5, that will be equal to 360. This is apply all the polygon. Okay, the sum of the exterior angle will be equal to 360. So remember that sum of the interior angle, it depends on how many sides, right? the exterior angle has to be equal to 360. Okay, right? This one. Okay, next one. Since you know all the exterior angles of a polygon is going to be 360, so we will have this one. The measure E of each exterior angle of a regular polygon, or you could angular polygon of n side is, you could divide it by n. Okay, each exterior angle, talking about like here, 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 here. But this is specific for equiangular or the regular polygon. Okay, you could have the E, the exterior angle equal to 360, the sum of the total angles divided by the side. How many sides do you have?
Could you ask the question again?
Mm-hmm. Okay, right? Okay, next one, polygons. I just covered it, but I don't think I'm gonna put this part on the exam, okay? I just let you guys know what is the polygon. Polygon is the star-shaped figure that results when the size of the convex polygon with 5 or more sides, okay? Only 5 or more sides you extend it. So when you extend it, we call this is, it will be make like just like the star shape, okay? Just like the star shape here. Okay, and then the polygons, like here, since we do have a 5 sides, so this is a pentagram, heptagram, octagram. Okay, again, we don't cover this part on, I don't put it on the exam. You may have the homework a little bit, okay, but I don't put it on the exam. I just let you guys know what is the polygons in here. Okay, and all these are regular polygons, means they all sides are equals and all angles are equal. Okay. Forget about it. Yeah, forget about this slide. Okay, so that will be the session 2.5. Okay, we're done for the 2.5. I don't think we have enough time for the session 2.6. But before that, that's it. Here it is. Okay, let me do some announcement. First, for the session 2.6, when you guys print out the notes, I want you guys print out this file also. I have only one page for the letter A to Z. It just look like this one. Okay, this is for the session 2.6. Okay, you can see letter A to Z. Okay, we need it for the classwork, one of the classwork. So next Tuesday, I need you guys print out the notes, session 2.6, and also the letter A to Z. I will have the session 3.1 ready by Friday. Okay, session 3.1. And also next Tuesday, we're gonna finish the chapter 2, and then we're gonna work on the construction chapter 1 and 2. You should find the construction pancake chapter 1 and 2 here. Hey, print it out. And remember, you guys need the compress Where's my compass? Next Tuesday, everyone need that way. Okay, I need like the protractor, the compass, the ruler, pencil. Okay, you have to get it on Tuesday. Okay, and this is like, I remember how many percent it is. The construction packet is gonna be 10%. Okay, 10% for total. And we're gonna do it together. Let me show you guys here. Okay, we're gonna do it together in class. So make sure you have your tools ready. It is pretty hard for you do it by yourself. Okay, we're gonna do it together during the class, and then you're gonna turn it in as just like the homework. And the construction packet is a 10% for your total grade. We only have 4 of them, 4 packets. Okay, so again, this is a easy percentage, easy grade you guys can get. Just come to my class, have the tools and the paper ready, do it together, and then you could submit it. Okay, and I'm gonna grade for it. It's gonna be 10% for your total grade. Okay, and I don't put the construction on the exam. Okay, on the exam, on the final, you don't need this one. Okay, but this is the geometry class. We need to do something like that. Okay, so make sure don't miss the class on Tuesday. We're gonna do it together. You need to have the construction packets and also the tools ready. So Tuesday, we're gonna finish the chapter 2, and then we finish this one, and then we have time, we're gonna work on the chapter 3 together. Okay, session 3.1. And remember the first exam that will be on March 8th, Tuesday, the chapter test 1. That will cover chapter 1 and chapter 2. I'm still working for the practice test, the sample test for you guys. So hopefully I should be done by tomorrow. So on Saturday, the latest you're gonna be on Saturday, you should see the sample test on the Canvas. Okay, I will create one things in here that will be the chapter test 1 here. Okay, so Saturday go online. But for this week, I want you guys focus to finish all your homework, chapter 1 and chapter 2. Even though only 1.5 to 1.7 and 2.1 due on this Sunday, if you have time, please finish the homework 2.2 to 2.6. Okay, so next week, you guys can focus on your test. When you have the practice test, I want you guys to do it by yourself so we can chat it out on Thursday together. Again, one more time. If you guys know how to do the practice test, you should be good on your test. Okay, and I will have a more information once